thank you very much. I would like to say it's a great pleasure to be here with you guys tonight, this evening. And yeah, thank you for the organizers for having me, for inviting me to talk. It's a great pleasure. And yeah, shout out to all the organizing for organizing this very event. So it's the very last talk of the evening. So I prepared something a little bit more lightweight to you, hopefully a little bit more inspirational, but still quite technical and quite detailed. So we're going to talk about the magic of continuous delivery. And I tend to have a focus on things that other people overlook. And the reason that I get fascinated with continuous delivery is I feel it's oftentimes overlooked. There is a very strong agile movement, and you can learn all about Scrum and Kanban and ceremonies and plannings and retrospections and all that stuff on one hand. And on the other hand, there is this whole DevOps movement with Dockers, automatic deployments and all that stuff. And I feel like oftentimes the meritum, the core, the most important part is overlooked. So today I would like to talk about what does it mean in simple, plain words. And continuous delivery is also, full of those words and meanings and names. And it's easy to, what is continuous integration? What is continuous delivery? This practice, that practice. It's really easy to get lost. So I'll try to explain a few of those practices, introduce those names in a very simple terms. And I'm going to talk about a few different platforms. I'm going to talk about web and cloud. So for many of you, when I talk about continuous delivery for web and cloud, that might be very natural, very obvious. For some of you, not that much. But I feel it's important to establish this baseline. So when we go to mobile and blockchain and Tesla and SpaceX, we see how those practices that were developed inside the web community, inside the cloud community, are now being applied or just getting started to being applied in other industries, in industries that are very fragile for hacking or mission critical, or even, where the people life depends on if the software is working properly or not. So let's start with the web. So continuous delivery. So there are, let's say, 4 most popular terms you might have heard about: trunk development, automated testing, testing environment, or staging, and automatic deployment. So let's look a little bit deeper into each one of them. So trunk-based development. So this is the idea, and I think this is still what splits the crowd, in a sense that I think maybe 2 decades ago or a decade and a half ago, there was this idea of feature branches. So I work on the branch, I develop my stuff, and when it's ready, I merge that into the main branch. And that turns out to be not the greatest idea. And one of the reasons is it's pretty difficult to merge something after a while. And the other reason is that if I work something for a month and then I merge it and there is a bug, it's kind of difficult to think when was the bug happened in the code, right? Especially if maybe on a specific day, there is several different merges and there is a bug. When if you merge something like on the daily basis and there is a bug, someone in the team is like, of course, I was working on that yesterday. That's probably where the bug is, right? So you're losing that context. So the idea of trunk development, and some of you old-timers might remember that what we call now main, before was called master, and before was called trunk, is simply a main branch in the project. And every single developer working on the project is committing or merging her pull request straight to the trunk, basically on daily basis, every few hours, maybe in extreme cases, and every few days. Now, every single commit, every single pull request that gets merged into master needs to go through the code review, needs to be properly tested, needs to go through all those different things, and so that when it gets merged to the trunk, it's a stable, fully working version, right? Occasionally, we might make a mistake, we might introduce a bug, but by definition, the idea is that at all times we have one stable branch that we keep committing small incremental updates. So for some teams, it's very natural, but some teams gonna find it very who finds it controversial? Okay, actually, just few people. So I aim for bigger controversy. I'm disappointed. So let's do we wanna take this right now? Okay. Okay. So why do you guys think it's controversial?
In my opinion, feature branches are inevitable if you plan to work on a big feature, and it does not make sense to commit on every couple of hours if you work on something huge and you might make mistakes and you do not do testing stuff, etc., etc.
It's a great point. It's kind of difficult to work. How do I build a one-month feature, right? That's a question, right? I got a nodding head, so that's a... Well, the idea is that I split this feature into small parts, into small refactorings, into small things. Sometimes I even bring new features that are not visible for the end users, right? I can pull a small flag in the code, we deploy that into production, but it's not visible for the user yet at this point. But I keep merging to the main branch. By that, I'm ensuring I'm not breaking the existing code, right? So this is very important. I think it's gonna feel much more natural when we go deeper into continuous delivery, and we can go back. If you still feel it's controversial by the end, let's talk about that some more. So automated testing, I don't think it makes sense to talk too much about it. I think it's a cliche by now to say, if you think seriously about automatic deployment and delivering stuff to production, often you need automatic tests. And I think that should not be controversial when I say, if you're seriously thinking about code quality, you have pretty extensive coverage with the unit test and some level of coverage of integration or end-to-end or both tests just to make sure you can iterate quickly. So I don't want to talk about this much today, but just to keep in mind all those things, all the work if you invest heavily in testing, in automated testing specifically. And it used to be when I was starting my professional career that there was a staging server or test environment or whatever you call it. But today we can speed up development so much and we can totally skip on staging server because we have this awesome feature called branch preview on GitHub. And it's available throughout all the different technology stacks. So you can preview the whole application, the whole new version. There is the whole testing environment per every single pull request. So you can click it, you can test it manually when you do a code review for your friend, or you can go to the product person and say, hey, come over, see if that's what you wanted. Or you can go to a designer, is that how you wanted that to work, right? So you can skip on all of that, one environment, everything is isolated. So when I merge to the master, I know it's tested, I know it's probably gonna, with high probability I can tell, okay, that's gonna merge successfully, the test's gonna pass, and it's gonna do what it does on the branch. And there is the deploy on green, where it all comes together and we say, whenever we merge to the master, it goes straight to production, right? As long as we didn't broke the master branch, which today is we have very high confidence because we can see that continuous integration server, then GitHub is giving them green on everything. We test it manually. We know it goes to the production. That being said, it's a great practice for the small teams. If you have 100 of users and you are 5, 10 guys, if you have thousands of millions of billions of users sometimes, and if you're a team of hundreds of people, the risk of deploying something to production is that breaks is just too big. Imagine only 1 in 1,000 commits break the master branch in Google or in Facebook that has thousands of commits every single month. Then we would have Google would break a few times a month and would definitely not have a reputation that it has today. So for those bigger teams, there are 2 interesting strategies we can put on top of deploy on green. One is blue-green deployments, when we basically have 2 identical production environments. We deploy on one. If we feel confident, it's good, we just switch the servers and now the new version is on the production. If we find that something got broken, we just switch the server back again and we have a very effective way of rolling back our changes in a matter of seconds or minutes. So that's something really worth considering if you have a little bit more users and you want to have more confidence when deploying to production. And for even bigger teams, like if you go to big tech, like Google, Facebook kind of size of companies, or even Spotify or similar, they have hundreds of servers. Every single microservice is working on hundreds of servers, usually even bigger products, over 1,000. So you deploy to one server first, then you deploy to 10 servers, then you deploy to 100 servers and 1,000 servers in stages. So it's called incremental rollout. I also find a name canary deployments. I'm not 100% if that is the same idea here, but the idea is that we don't deploy to everyone at the same time. We do it stage by stage and making sure that everything is intact in the meantime. So, and it's really easy on the web these days. I used to code a few years ago, so we would use Netlify and Heroku. Today, I see the teams I work with using more modern stack like Warsaw and Subbase. This is our software as a service in the cloud. If you want to host it on your own, there is a cool startup called Coolify. I see they're getting some traction. So you can host it yourself and have all the beauty of continuous delivery with them. And usually GitHub or GitLab are effectively the continuous integration server, the place GitHub Actions run all the tests and checks and trigger deploys when everything is all right. What's the name again? .cool? Okay. All right. Well, I honestly seen a lot alternatives. It was so, just a few years ago, it was really hard to find anything, really. Like Heroku, if you want to do a branch preview, it was really difficult. Now there's just so many options, which makes me very happy. So, okay, so why we do that? We want to have fast feedback loop. With fast feedback loop, we can have happier users. If there is a typo, a small bug, we can just fix it and push it to production right away. It's not an exceptional situation, it's a normal situation, right? Better communication with business, they see it on the live preview, they see it on production quickly, and A/B testing, really easy. Testing with users on production, very easy. And it works great for teams' morale. There is nothing better for engineering morale than shipping, is a quote from a good friend of mine who is doing engineering management for over a decade now for one of the big tech companies. All right, very impressive, very nice. This is all web. This is like, did I say anything really new and revealing for any of you guys? Is that all obvious? It's kind of, yeah. Kind of, to some extent, every one of us is doing that. But it's getting much harder when we go to mobile. And it's gonna get much harder as we move on to different environments. So the biggest challenge in mobile is that we have App Store. So when we deploy a new version, it effectively means we put it into the App Store and we patiently wait for the Apple to review the app, which might take a few days, might take a few weeks. Theoretically, it takes 3 days. Practically, it might take as much as a month. And we wait for this version to be accepted. Moreover, when it gets accepted and some people install it, some other people have the older version, and some other people have the older version, and some people have the older version, right? It makes it really difficult to do continuous delivery, A/B testing, all those things we talk about on the web is suddenly impossible. And predictability. And what adds even more complexity, you need to, this fragmentation of application also kind of goes down into deeper into the stack, into API versioning. So now our backend server API for the mobile application now needs to support all the different versions of the applications that we still see in the wild, and there is no easy process to force users to update to the newer version. So there are two solutions. So someone is already hinting us here in the audience. So one is server-driven UI, and that's a toy for big toys. That's a toy for big boys, like big tech companies. So we ain't gonna talk about it. That's what YouTube is using. That's what Spotify is using. That's what many different companies are using. But if you're a smaller team, what you might want to look at is code push, which is a technology perfectly available to smaller teams. So it works greatly with React Native, which is, I believe, I'm not an expert on mobile, but I believe React Native is, I think, the leading technology that allows to do that. And there's this idea that application in the React Native is split into native and let's call it dynamic part. So you have App Store installed native application, Google Play native Android application that runs a dynamic JavaScript code inside. And that kind of translates to native experience, to native widgets. So with code push, you can force push to the users the new version of the JavaScript code. So if you want to make changes in the native code, you still have to go through the old cycle, but that happens very rarely. That only happens when your application needs to access new native capabilities. So we're talking about new devices in the application or new permissions. Everything else can be done perfectly via React Native. So all the little changes can be pushed. It's important to remember to compress those divs because that can kind of become pretty big at some point. So here's the idea explained on the chart. So if I'm a user and I have a mobile phone, when I open the application, it checks to see if there is a new version. And if there is a new version, it downloads the new version. And it only works, and it kind of forces me to use the newest version. That being said, that's just the half of the pipeline, of the delivery pipeline, because the other is we still want to update those native applications in the app stores, because when user install the new iPhone or Android application, they want to have fairly newest version. Maybe download a small update, not like the whole 3 years history of that, right? So there are two cycles. One is very fast. I can push updates on daily basis, multiple times a day. We can push deploy on green. And there is a slow one for the big features and to making sure that the version users have installed, the version that fresh users are going to install is not that different. All right, so that's pretty cool. There is implication for API. So I would like to tell you, you don't need to version your API at all. That would not be true, because the whole update there might be users that might not be able to update instantly. You want to be able to roll back easily. If you deploy if you break the application, you want to be able to push the older version without redeploying the servers. So usually you support two versions. But the way you do it is you do it in the code, right? So you have a new and old API endpoint. You introduce the new endpoint, you run it for a week. Everything looks fine, you remove the endpoint at the end of the week. So you introduce a new feature, test it on production, remove it, and so on and so forth, right? So this is much, much, much more dynamic and much, much simpler and much easier than supporting, 5 different versions, which is pretty much standard for a long-living applications in the app stores. Some considerations, you probably want to have end-to-end on-production tests. So you want to have something that after deploy clicks on the mobile that is connected to the production server that allows you to quickly discover if there is a major bug in the application so that you can do the rollback. I put monorepo here, but probably if you do continuous delivery, you want to do monorepo anyway and have one building process. But the general idea is it's really important to be able to discover and deploy together everything, and just monorepo makes it much easier than storing those things into multiple repos. And one thing to remember, we talk about incremental rollout. Now we can do incremental rollout to devices. We put it to 10% of the user, 1% of the user, right? So this is really cool feature as well. Again, you can use all those techniques discussed on the web. This is a lot of work, It was a lot of work on the web to utilize those practices. Now it's a lot of work. It's not a lot of work on the web anymore because we have all those different wonderful technologies, but it is kind of still a lot of work on the mobile. but it is a fundamental investment into team productivity, and you probably do want to allocate some time making sure that you keep improving the delivery process, not necessarily everything at once, step by step, see where the biggest pains are first. All right, and those are the two technologies. Bitrise, someone recommended Bitrise to me, and also Microsoft App Center has a technology called Code Push that tremendously helped to set it all up. All right then, so let's talk about the blockchain. So blockchain is where I personally spent last almost 6 years. And here is the challenge with the blockchain. It's very different than the challenge with the mobile. Give me just 1 second. So the problem with blockchain is you have those smart contracts. And smart contracts are basically small programs written in Solidity that manage money, business logics and money. The money is on the smart contract. The smart contract is in charge of the money. So if there is a simple bug in the application, it can be utilized as a hack. The money can flow to a hacker. And there is no court in the world today. There is no, well, police is kind of looking for those guys for better or worse, but it's really difficult to get that money back. And the reputation, well, the money is a lot, and you can see here's a list of hacks that happened, throughout several years. This is not exhaustive. You can see on the top you have like over a $500 million hack, $500 million of users' money. It's gone. And even the smaller hack from the bottom of the list is, $250,000, right? So a lot of money loses a lot of people loses a lot of money. That's not good. They're pretty angry, and there is a reputational damage for the startup, right? And, even might be a criminal responsibility for startup founders, depending on the jurisdiction and situations and whatnot, right? So that's the challenge. That's the challenge with creating software on mobile, and even more with continuous delivery. Now we put to the branch, deploy on green, boom, $500 million's gone, right? So there is an extensive list of security practices we can utilize. So extensive testing, of course. Rigorous code review, no doubt. The bug bounties. So we pay people to look for the bugs in the code, and if they find, they can get the bug bounty. Sometimes hackers prefer to take the bug bounty instead of taking the money, right? And there is external audit. And external audit takes about 2 weeks, depending on the size of the code audited. Maybe the other way around. At least 2 weeks, unless it's a very small change. And then the report comes back. Let's say team is very agile, very good. There's not so many feedback in the audit, so it takes about a week to apply all the changes recommended by the audit. And there is yet at least another week of the auditing team checking it, like, okay, this change was applied, yes. This change was applied, yes, okay. And then the auditor says, yeah, it's good, right? So that's a month, right? So it just can't deploy to production, right? So we were trying to shorten the size of the batch that goes to audit, and we started with 6 weeks. It was too small. We were not able to develop a reasonable size feature. The auditors were not able to audit in a reasonable time, and we believe 3 months is the lowest you can get with reasonable organizational overhead. Also, I think it's worth to mention that those auditing firms, they're mostly crappy. There is a few good auditing firms that you have to schedule this audit months ahead because they have long queues. So that's another problem, right? You cannot just call the company and say, we're ready for audit. You have to schedule it 3 months in advance. Usually, sometimes half a year, sometimes 2 months, but never almost never next week. So we find that this is the process we're able to support. And then it goes, after the audit, it goes to the production, right? So we thought, 3 months is already much shorter. I believe most of the startups maybe do 2 releases a year. So this is already much shorter than most of the startups. So we thought, how can we make it better? And we don't think we can shorten it significantly more than 3 months. So what we can do to increase security within that within that frame, and what we can do to deliver more within these 3 months. So we build our internal security team that works in parallel to the dev team. Unlike the auditing team, who is reviewing the code, the internal security team has much more time. It doesn't have 2 weeks. It's not constrained by this very strict agreement with the external company. And this team can be more involved in designing of the software and can be more involved in the whole spectrum of security-related things that happens in the company. But what they do, the most important part of what they do is they try to find bugs in the code of the team as they write code. And what they do is very interesting. There is a very interesting tool called formal verification. So formal verification, and it's going to be a great simplification. So if anyone here done formal verification, please excuse me. You can think about formal verification as a type of testing. But when you write a test, you write a test for a single case. So you have, for that input, this should be the output of the function. When you write a proof in formal verification that is equivalent of test, what you do is you say, for any input, we expect that output gonna satisfy this condition, right? So it covers all the edge cases with a single proof. So that's a little bit more complicated, takes a little bit more time to develop, a little more time to run, but we are now able, we're using technology called Certora, which is the first technology that allows you really to run those proofs in continuous integration. So that's very important because it catches a lot of those edge cases that you might not be thinking about. And here is production to deploy to production. It's quite complex because, you know, in the context of web, you just deploy to the server, right? This is not how it works in the blockchain. In the blockchain, you have DAO. DAO, which is like the bunch of people in the smart contracts, and they say there is a new version. Does the community agree to use the new version? And they vote. And you propose a new smart contracts, and they vote for 2 weeks, and then you deploy, right? And there is a time delay, so every single person that is not happy with the changes can exit with their money on time, right? So it's quite complicated. It's important to automate that, and it's important that security team is also reviewing the deployment scripts. But also there is this other situation when there is a hacker, perhaps using bug bounty, and he found a bug in your code. And now you have to deploy it. And there is a known bug. Well, there is now a bug known to a hacker in the team, and you want to deploy it and put everybody through the voting and, you know, and like everybody see the bug, everybody can exploit the bug, and he has a month. So if he's a really lousy developer, he still can do that, right? So often there is also developer multi-sig, where there's a bunch of developers, and they are able to deploy in secret. So when that happens, it's important to fork repositories private, fix the bug locally, and deploy it in a single transaction not visible to other users on the blockchain, because it happens in the past that many hundreds of millions of dollars were lost because the bug was revealed on GitHub before it was actually applied, right? So just to give you an idea, the deployment is non-trivial. So if we want to speed up the development and increase security in the same time, which is, by the way, most people gonna tell you, you know, if you keep deploying to production, it must be unsecure, right? Well, not necessarily if you implement the proper practices. So we were able to shorten the cycle. Why increase the security level? And by the way, the security practices could be easily, you know, a few presentations like we have right now, going through the different things you can do to ensure the code you're creating have a minimal risk of being hacked. And then there is the whole automation, government, and emergency updates. So there's the whole aspects of deploying to production that you want to automate. But that is all slow cycle. So like in mobile, so this idea of having fast and slow cycles is going to be very familiar in different spaces, right? So in mobile, we have slow deployment cycle for native stuff and fast deployment for dynamic part, for the React native part, right? And similar you can do in blockchain. You have this slow upgrade cycle for the smart contracts. But for all the infrastructure related to that, so for all the web application, there is a web UI talking to the smart contracts, maybe a backend, maybe the graph script. So for those of you who are familiar with the blockchain, there are all those things, and all those things can interact with the smart contract, but this can be updated many times during the day. So if you want to look at the chart, this is how it works, right? We have developers who commit to a repository. It's a monorepo. It has all the different parts of the stacks. It has smart contracts and the next version of smart contracts. So it's very similar, again, to mobile when you had current API and previous API, right? So this, every single update here goes through the continuous integration servers that run formal verification. Those we don't touch at all. Those are immutable unless there is an emergency upgrade that needs to be done. And those things, they keep being deployed through CI/CD server, straight to infrastructure, versus local graph, whatever you want it to be. Now there is just a single version of a front and backend subgraph. There is many testing environments. Every single PR has a branch preview, so you can test with the product, with other developers. You can test it, including the test smart contracts that are being deployed to the test network, right? And that is all available on production, because if you go to the application, you can switch the network. You can go to the testnet or to the mainnet. So if you switch to the testnet, you can access the test smart contracts and you can access new features, right? Like we discussed. When you develop big features that takes a month or 3 months, you hide it for the users on the production, but they can see it on the testnet, right? And then, once you're ready, developers can automatically, through the smart contracts, propose new version, either for the voting, for the DAO voting, or through the multi-sig emergency upgrade. So that, my friends, is blockchain. And as you see, heavily inspired by continuous delivery in other industries, I think it's important to emphasize we increased, not decreased, the security significantly, and we significantly speed up slow development cycle while keep fast development cycle that is on the web, that we get used to working on the web, but is not standard in the blockchain industry. So before we go into the questions and before we finish conference, I would like to point out a few examples of the practices we discussed today, how they're being applied in life-critical, mission-critical, very difficult environments, because I feel like sometimes when you talk about continuous delivery, people might be like, okay, that's a nice toy for web and maybe mobile, and maybe this blockchain guy is, right? But for the serious stuff, like banking, like hardware, where life people is at stake, you need to have a serious approach to the software delivery, right? So I would like to counter that belief with some examples of this practice we discussed are being used in Tesla and SpaceX, and they push it far further than anyone I'll know about, and just want to for inspirationally want to share some of them. I'm not familiar with all the different details, but they do share a lot during investor days and during different leaks, and you can see different leaks, people talking in different presentations, how things are going there. So first of all, Tesla has this idea of over-the-air update, right? So the software in your car, and that touches every single computer in your car, which is plenty these days, which is like you have electronics in your door, you have your ABS, you have your computer, you have your music and all that stuff, right? You have Autopilot in Tesla, right? So all of that can be upgraded over the air. And normally you connect to the Wi-Fi, the new version is downloaded and then upgraded. But again, we see a pattern here across the different platforms. There is an emergency update. And the Tesla has this LTE capability, which is used for Spotify, for maps navigating. You can basically browse internet in Tesla, right? So if there is an emergency update, it can be downloaded via GSM network, basically. So, and Tesla is known to introduce new features one of my favorite features, which is, well, I don't have a dog, but it's a funny feature. So they introduced the dog mode. So if you have a dog and you want to close it in the car, like and it's hot outside, it's usually a big issue. The animal is suffering and so on and so forth, right? There is a dog mode. You can leave the dog in your car. The air conditioning is on. On the screen, there is a big label that says, hey, it's a dog mode, everything okay, I have air conditioning, I'm fine, right? And you can check if everything is fine with the dog, right? And you can get a notification if the dog is barking loudly, right? So this is the feature that was introduced over the air as an update, no new hardware, and there's a lot of features like that. A lot of features like that was introduced that way. And I think the most profound piece of software that Tesla is building is Autopilot, which became very popular and controversial over time. And I think the level of effort they put into Autopilot to build it and into process of building is just amazing. So first of all, the tests. They have short few second inputs, like basically input from 8 different HD cameras and all the different other sensors, and how does the car should behave. And they have thousands of these cases, like car turning on the crossroads, moving forward, accelerating, deaccelerating, you know, how do I behave when there is an accident on the road and so on and so forth, right? Those tests, every single thing, every single new version that basically get merged into a branch, into a master branch, needs to go through all those tests. There was something on the screen. What was that? All good? Good. And they have a shadow mode. So every single Tesla at every single point of time is running Autopilot in the shadow mode. And the shadow mode is comparing the decision of the driver or the Autopilot driving in the non-shadow mode with the shadow mode Autopilot. And if there are differences, they are used to measure the accuracy. How good is our new version of Autopilot, right? So again, we have 2 versions, right? The current version and the next version, right? And they're being benchmarked for like 2 weeks before actually being deployed to the production. The shadow mode is also a great source of learning because they are able to query network and tell me all those different situations when the Autopilot didn't behave as the driver expected, right? And they can then query the network, say, give me all situations that are similar to that situation. And they create a new tests that we have on the slide in the upper half of the slide, right? So this is very interesting. Also, Elon personally and many company employees are known to drive the next version of the Autopilot before it gets deployed to the production. And to give you an idea how huge investment it is, they build their own computer for the car. It's the one on the top. And they build their own computer, their own processors for the computational center when artificial intelligence learning, where neural networks are learning. And each of those projects is multi-billion-dollar project. To build a processor, a custom processor from scratch costs more than $1 billion, right? So those are the investments they do into those processes to learn faster, to be able, and first of all, be able to work with such a big models, but second of all, to be able to iterate them faster. And some examples from SpaceX. So SpaceX, first and foremost, has very advanced physics simulator. So when they write tests, you could say the equivalent of unit tests is just running those on physics simulator, right? So you build a part of software for navigating the rocket or navigating the Dragon, and you run it in a simulator. And then the acceptance, the equivalent of end-to-end tests, I would say, is a test bed. So there's a physical table with every single mock of every single device, of every single, like there is engines, there are griffins, there are all the different monitors that are plugged into that. And the whole flight is being simulated on the physical mocks of devices before being merged into the master branch. And Tesla is known to upgrade software to the very last minute, even up to an hour before the start. So this is the level. So on one hand, you could say it's not responsible to upgrade software 1 hour before launch. But on the other hand, yeah, but they have so much more confidence that any other space program, because they do very extensive testing that is not available to, at least to my knowledge, to those other space programs. And last but not least, I think that's just a beautiful, very simple and beautiful idea. There is a Starlink satellite network that is now, I think, over 10,000 satellites running on orbit at all times. So they do, it feels very, I don't think anyone will be surprised, yet I still find it somehow satisfying that before they deploy to the new version of I don't have to tell you by now, they keep updating software all the time to those satellites, but they first deploy to one satellite, observe it for a little bit, and then keep rolling it out to everything and doing incremental rollout that way. So I hope it was inspiring. I wonder if that is still controversial, if that feels like something you already do and is obvious, or not at all. If you would like to continue conversation online, you can find me on Twitter at @ETHMarek, and I think we still have time for a few questions.
So, Marek, thank you very much for your talk. This is very wide and covering a lot of topics. I'm very glad that it was the last talk today, because it's very eye-opening. However, I have one question, and this is, you have covered a lot of topics, but I'm missing, however, I'm missing one thing here, and this is for me the golden standard in open source community, and this is how is organized development of Linux kernel. Because all of this, what you have described, what you have shown, they origin, in my opinion, from Flow, which was brought to the open source community by Linus Torvalds. And my question is, my comment is that we were missing, from my point of view, we are definitely missing Linux kernel mentioned here. So I think you can fix that on your slides. But my question is, what is the most sophisticated, complex open source configuration, which according to your knowledge, and I know that you are experienced in blockchain, which all of us here, we could follow, we could read, but I would like this to be open source. That's why I'm asking, not Tesla, not SpaceX, based on your experience. You don't have to answer it now, but it would be great if you would post it in your Twitter or something. Thank you very much.
All right. Thank you for your question.
All right, I will try to use that microphone. Is that good?
Yeah.
All right. So, so I think I disagree when you say I would love to bring Linux kernel here, and I think have a great respect towards Linus Torvalds and the whole team. I don't believe I would classify what they do as a continuous delivery. I believe they work on feature branches, and they only merge something when they feel it's very stable. And they have pretty slow process, but they still stick to some of those principles, like keeping features small. So they, for example, rejected NVIDIA, 3,000 lines of code driver, and there was a huge beef between Linux and NVIDIA back in the days, because it's really difficult to review 3,000 of code, right? Even by the badass developers in Linux kernel. So that's another reason when you want to do trunk development, it's just impossible to review pull requests that have hundreds or thousands of lines of code. So I believe Linux here not necessarily deserve to be mentioned in the context of continuous delivery. Great respect, regardless. The other thing is, I think we could bring many more examples of doing great continuous delivery that I am personally very inspired by. This presentation, I believe, is already a little bit too long. So Just a little bit. If we would start dig deeper into different topics, it would probably take a few hours or few days. So it was really difficult to pick the right topic. So I tried to have a high level overview and grasp the idea in few different contexts. When it comes, I'm not sure if there is any specific open source projects, and the open source projects in general not necessarily have a tendency to use continuous delivery because they are open source. So there is usually not a server to deploy to. So it's really hard to point to any specific one. I'll look for that and try to put it in a comment on the YouTube though. One more and then we go. Is that?
You have 3 seconds for the question. 2, 1. Thank you, Marek.
Thank you.